For a century, general relativity has taught us that gravity works like a bowling ball resting on a trampoline. We are told that a heavy mass bends a flexible, four-dimensional grid called spacetime, and smaller objects simply roll down these curves. But this visual shatters the illusion. That grid is a mathematical map, not a physical territory. Einstein's tensor mathematics perfectly predicts gravitational behavior. The equations work. However, the model completely lacks a physical ontology. Spacetime is not a measurable substance you can collect in a jar, weigh on a scale, or analyze in a lab. This exposes a philosophical flaw at the heart of modern physics. Mathematical abstractions and coordinate systems do not possess physical causal power. A geometric concept cannot reach out and pull a planet. Spacetime curvature is a mathematical fiction. It serves as a highly accurate calculator that happens to perfectly mimic a real physical mechanism known as vacuum refraction. Vacuum refraction is simply the process of light and energy bending as they travel through a physical medium of varying density. To resolve the paradoxes of modern physics, we have to stop adding geometric epicycles. We must replace empty mathematical space with a physical medium, and in doing so, restore a strictly deterministic reality. This requires adopting the foundational axioms of one-field theory, or OFT. OFT is a framework that derives physical phenomena directly from continuous electromagnetic fields, rather than abstract geometries. Under OFT, space is a perfectly flat three-dimensional arena. Time is strictly a forward-flowing parametric clock, not a tangled fourth dimension. We also have to redefine the vacuum itself. The vacuum of space is not an empty void of nothingness. It is a real, polarisable electromagnetic medium possessing intrinsic physical properties, specifically permittivity and permeability. These two properties dictate the vacuum's exact capacity to support electric and magnetic fields. Even in deep, isolated space, far from any stars or planets, this vacuum is constantly active. It supports miniature, transient electromagnetic field displacements, creating a continuous baseline of dipole activity across the universe. This baseline dipole activity acts as the fundamental speed limit regulator. It determines the ambient global speed of light, known as c0 in undisturbed space. If the vacuum is a physical, polarisable fluid governed by electric and magnetic properties, then gravity must fundamentally be a fluid dynamic process, rather than a geometric warp. To understand how this fluid works, we discard the standard model concept of zero-dimensional point particles. Matter is instead composed of monopolons. A monopolon is a finite, self-sustaining knot of electromagnetic field energy, a stable soliton. The intense, concentrated field energy tightly bound within a single monopolon continuously agitates the vacuum medium immediately surrounding it. This extreme local agitation stimulates a much higher rate of transient dipole activity compared to the calm baseline vacuum of deep space. This sets up a crucial physical relationship. A higher density of dipole activity directly equates to a higher vacuum polarizability. In classical optics, this elevated vacuum polarizability acts exactly like a higher dielectric constant, represented by the letter K, in a material like glass. The dielectric constant measures a substance's ability to store electrical potential energy under the influence of an electric field. This completes the causal chain. An increased dielectric constant strictly enforces a slower local speed of light, or c local. The thicker the medium, the slower the propagation. This chart shows how that field agitation naturally falls off with distance from the central soliton. As the distance increases, the agitation drops, creating a spherical spatial gradient in the refractive index. Mass does not warp the geometry of space. It physically thickens the local vacuum, turning the universe into a graded index optical medium. We can scale this microscopic mechanism up to planetary sizes. Inside a star, trillions of monopolons aggregate. Their combined electromagnetic agitation creates a massive, deep vacuum gradient extending millions of miles into space. Light traveling through this massive gradient follows Fermat's principle of least time. Fermat's principle states that the path taken by a ray between 2 points is the path that requires the least time to traverse. Consequently, the light physically bends toward regions of slower propagation, areas with a higher dielectric constant. This simple optical bending perfectly replicates the gravitational lensing observations recorded during the 1919 solar eclipse, the exact measurements that made Einstein famous. The Shapiro delay is light slowing down as it wades through a thicker dielectric medium. This approach yields the exact Schwarzschild metric without curved dimensions. Black holes are simply regions where an extreme refractive index drops the speed of light to zero, creating an optical event horizon. For the propagation of light, gravity is not non-Euclidean geometry. It is entirely classical optics. This optical framework also resolves a 300-year-old physics mystery. Since the days of Galileo and Newton, the exact equality of inertial and gravitational mass has been accepted as an unexplained coincidence. Einstein used this unexplained equality, known as the weak equivalence principle, as a raw, unproven postulate to construct the foundation of general relativity. OFT defines these concepts strictly through physical interaction. Inertial mass is the physical resistance a confined field structure exhibits when it is forced to accelerate through a uniform medium. Gravitational mass is how that exact same confined field structure responds when placed in a spatial gradient of the vacuum's refractive index. A structure's internal confined energy is mathematically dependent on the local speed of light. Placing that structure in a light-speed gradient creates a literal physical force, pushing the internal energy toward regions where the speed of light is slower. Inertial and gravitational mass are not miraculously equal. They are the exact same property, confined field energy, measured in dual physical configurations. One measures resistance to uniform acceleration, the other measures response to a spatial gradient. General relativity encodes this equivalence geometrically by construction, but it fails to explain why matter behaves this way. It maps the trajectory without identifying the engine. Objects do not fall because they are blindly following a geometric geodesic. They are actively steered downward by differential refraction across their own finite structures. Establishing the macroscopic nature of gravity clarifies another long-standing pursuit. For decades, physics has poured billions of dollars into the search for the graviton, a hypothetical particle meant to unify quantum mechanics and general relativity. If gravity is a macroscopic statistical gradient in vacuum polarization, attempting to quantize it is a fundamental category error. Searching for a quantized graviton is exactly like trying to find a pressure particle by examining a single molecule of air. Pressure is an emergent, collective property. Gravity is exactly the same. This reframes the data we collect from facilities like LIGO. Gravitational waves are not ripples in the fabric of spacetime. They are physical, longitudinal density waves propagating through the vacuum's polarization. The search for quantum gravity is an impossible pursuit. Gravity is an emergent, classical field effect that requires no quantization. Dismantling the geometry of gravity forces us to challenge a deeply held assumption of modern physics: the idea that all causal propagation in the universe is limited to a single universal constant, c. OFT replaces this with a three-speed hierarchy. The first tier is c local. This is the position-dependent transverse wave speed that we measure locally in our laboratories. It slows down near mass. The second tier is c global. This is the baseline transverse wave speed in the ambient, unagitated vacuum far away from massive bodies. The third tier operates entirely differently. C longitudinal is the speed at which longitudinal disturbances, like vacuum polarization changes and energy redistributions, propagate through the medium. Think of a taut steel cable. Shaking it side to side creates a slow transverse wave, but striking the end creates a longitudinal sound pulse that travels through the steel vastly faster. The two speeds are governed by different physical properties of the same medium. The vacuum operates under the same mechanical logic. Longitudinal energy adjustments can propagate through the vacuum orders of magnitude faster than transverse electromagnetic light waves. The Minkowski light cone is the standard geometric model used in relativity to map the path of light through spacetime, and it is universally treated as the absolute boundary of causation. But it only represents the speed limit of a transverse wave mode. It fails to represent the ultimate limit of causal access in a universe. We can apply this shattered light cone to Bell's theorem. Bell's theorem is a concept showing that certain quantum mechanics predictions cannot be explained by local hidden variables, often leading physicists to conclude that particles communicate via spooky action at a distance during quantum entanglement tests. Quantum Bell tests mistakenly enforce space-like separation only relative to the slow, locally measured transverse wave speed, see local. When a detector absorbs energy from an entangled field, that energy subtraction does not travel at the speed of light. It propagates longitudinally through the vacuum at the much faster c longitudinal. Because c longitudinal is vastly faster than c global, this energy redistribution happens effectively instantaneously in the preferred frame. The process fully preserves deterministic causality without violating any physical laws. This chart shows the necessary replacement for the Minkowski spacetime diagram. A wide outer causal cone, representing longitudinal adjustments, encloses a much narrower inner light cone, representing transverse waves. By stripping away mathematical fictions and restoring a physical, multi-mode electromagnetic fluid, physics no longer requires metaphysical paradoxes, unobservable dimensions, or quantum magic. The universe operates through clear, deterministic mechanics.